Here we are with another new video on our hashing series. The problem is find all the anagrams in a string. So we are given with two strings, yes and p, written an array of all the start indices of p's anagrams in yes. You may written the answer in any order. So we are given with two strings, that is yes and p. Wherever you find whichever index in yes, if you find the p's anagrams, then you have to written those index in the array list, because here in the question we are asked to written a array list. Let's visually analyze this problem so that we understand how to come up with a solution. So this is the visual dry run of the question that we have. This is the given string and this is also a given string, that is p. So we will be solving this problem using a hash map to keep the track of frequency of both yes and p, and we'll be using sliding window to keep the track of the characters of string p. So this is how the sliding window works. So at index 0, the window size is 3 and we'll have first 3 elements of yes, characters of yes. So if you compare that, if you create a window map from that, you'll see that every character in the window with the has frequency of 1, and this should match with the frequency of our p string. So all the characters are appearing once, and that matches with our window, so it's correct. And we write the matching index within our array list that we are returning. That's why there is 0 over here. Then we go to the index 1, which contains the next three characters. So even when you calculate the frequency, you have this extra character, that is e, which is not present in our p string. So it doesn't match, so we're not going to return this index. Next, moving on to index 2, we have a, e, b. Here again we have e, which is not present in our p string, so it doesn't match. Then we have EBA at index 3. Here again we have this E, so it doesn't match. Then at index 4 we have BAB. Two B's are appearing in this window, so it doesn't match with our string P. So here again we are not adding this into our index. Then coming to fifth index, we have BABA. A is appearing twice. Again, this doesn't match. Then sixth index, we have BAC. This is an anagram of our string P. So the frequency of all the characters present is 1, which correctly matches our P string. So we'll be adding this index into our answer array list. Then moving the slide to the next step, that is next index. That is where we reach index 7. A, C, D. D is not present in P, so we can't return it. It doesn't match. Now let's talk about the algorithm. Firstly, we will have to create an empty array list to return the answer. Let's start coding. Array list integer. Let's name it as ans new array list. Okay, next we will have to do if p is longer than yes, then return an empty list. See, of course, we are checking the anagrams of p string. So this p string cannot be greater than in the sense the length of the p string must not be greater than the length of the yes string. So that is one edge case we'll be testing out here. That is yes length is less than p dot length, then we need to return an empty string like this, empty array list like this. Then according to our algorithm, we will have to build a p map which stores the frequency of characters in p string. So HashMap character and integer, because we are storing the frequency of our integers. P map is equal to new HashMap. Now calculate the frequency. Char c from p dot to char array. This is the exact function which is used to convert a string into character array. And then we will be calculating the frequency using p map dot put c, which is the character, with its frequency. Now how do we calculate the frequency? Using this function from hashmaps dot get or default. Get the frequency, or defaultly you put the frequency of character c as 0. If it's already present in the hash map, then add +1 to the frequency already present in the hash map. That's how this works. Okay, we are done with calculating the frequency of p string. Now moving ahead, we have to create an empty window map. Now here we have to create one more hash map to calculate the frequency of the characters in the window. Again, character comma integer window map is equal to new hash map. A typo error. Okay. Then we need to traverse yes using the right pointer. Add yes of right into the window map. Before that, we'll need our the size of our window, right? We will name it as window size is equal to p dot length. Then we'll create a slider int right is equal to 0. It starts from 0. Right is less than yes. From where are we moving it? Against what? Yes, right? Length of yes right ++. Okay, here we'll have to get the character. Let's say it has add. We need to acquire the character add as the right moves across the string yes. So let's say add and yes dot char at right. Okay, now we need to add this character into our window map with its frequency. Window map dot put add comma window map. Why am I making a lot of typo errors today? Sorry, get or default add comma 0 plus 1. Okay, now that we have added first three characters from the string, now what if the right reaches window size? Now when right reaches window size, we need to remove the elements from the left. Right? See, look at here. If the window size becomes larger than p dot length, that is the window size. This is the window size. Then we need to remove the leftmost character. If its frequency becomes 0, then remove it from the window itself. This is the logic we are doing right now. Let's do it. So if right is greater than or equal to window size, then character at left is equal to yes dot char at see left. How do we calculate the character at right? That's simple. Right minus the window size. Okay, this gives us the leftmost character, and then we will recalculate the frequency. Now we have removed the leftmost character, right? Now we need to remove it from the that frequency, from the window map frequency. So dot put left comma window map dot get of left minus 1. Okay, now the frequency is correct. Now what if the frequency becomes 0? Then we have to completely remove it from the map. So if window map rar map dot get left becomes 0, then window map dot remove it from the map itself. Okay, we are done with this much. Now moving ahead, what should we do? Okay, this much is done. Remove it from the window. When the window reaches p length, compare window map with p map. This gives us if we have to add that array index into the array list or not. Okay, now if right is greater than or equal to window size. I hope you guys understood why am I doing this condition, because see, if the window size is 3 and we are checking this condition, that is window map is equal to p map, then it can check for even 1-2 characters, right? 1-2 characters that we have in our map. But no, we don't want that. We need proper conditions, like right should be greater than the window or it should be equal to the window. Then only we need to check the condition, main condition, that is window map dot equals p map. Then ans dot add, we are adding that index to our array list. Right minus window size plus 1. Okay, then we will return ans. Yes, now it should work. Oh my god. Oh, our 0 is not getting added. Why is that so? Oh, here it should be greater than window, right? It should not be greater than or equal to. Oh, again, it's a wrong answer. Oh, here we ended up with the same solution as the last one. So, according to me, there is an error over here. With this condition, see, right is greater than window size. Window size is 3. No, yes, okay. Right should be greater than or equal to window size minus 1. Because, see, our what indexing starts from 0, but the length of the string is 3. Over here, take this example, the length of the string is 3, so our window size is 3. So now what happens is our right should be equal to 3 or it should be greater than 3. It should be equal to 3 or it should be greater than 3. Got it? It should be in A or it can be anywhere else. Then only you have to check this condition, that is window map equals to P map or not. Otherwise, the string will be less than what is required to be compared with the P map, right? I hope this is clear. Now let's run the test cases. Now it should be graded. Yes. Let's submit. Now let's talk about the time complexity. So the time complexity of this solution is big O of n because each character enters and leaves the window once. So the time complexity becomes big O of n. And space complexity is big O of 1 because our map can contain only 26 elements, because in our question we are given with only the small letter characters, lower characters, not capital letters. So small characters are 26. It's constant, so space complexity becomes big of 1. Thank you for watching this video. I hope it was helpful.